Hello, good morning, good afternoon, everyone. Welcome to this live stream webinar brought to you by CrateDB and EOT. Today, I'm very happy to address and to talk about a very interesting topic about DIY machine learning for industrial operations in energy and manufacturing. For that, I have two guest speakers from EOT, Matt Oberdorfer, CEO, and Sharon Allpress, VP Strategic Engagements. Welcome, Matt. Welcome, Sharon.
Hello there. Happy to be on the show.
Very happy to have you here. Maybe to get started, would you mind introducing yourself very quickly before we get started?
Yeah, my name is Matt Oberdorfer, and I'm the CEO of EOT.ai. We focus on bringing industrial operations and AI together. We are a software company globally distributing software solutions to industrial energy, transportation, manufacturing, and oil and gas companies. And that's it. That's my intro.
Thank you, Matt. Sharon, would you mind introduce yourself very quickly? I'm not sure she can hear us. Hey, Sharon.
Hi.
Can you hear us?
I can hear you a little bit. I'm getting a lot of feedback.
Okay. If you can introduce yourself very quickly, introduce what you're doing at EOT to the audience. Apparently
sure.
She can hear us.
Hi, Sharon Allpress with EOT. I lead our strategic engagements and partner program. And I've been in the industrial sector for my career, building software for operations. I'm really excited to be here to talk about what we have with machine learning, do-it-yourself Workbench.
Thank you. Happy to have you here. So maybe to get started, so this is what we are going to cover today in this session. We are going to cover the very interesting topic of the bridge, covering the bridge between bridging the gap between OT and IT, and how to empower data scientists and operations team to seamlessly integrate machine learning models with real-time industrial data. And also, scaling is very important as the volume grow, and how to scale easily and avoid performance bottleneck. So there is an interesting challenge here. Sharon would like to introduce. I don't know if you can hear us very well, Sharon. She seems to be disconnected. Maybe we'd like to take it, Matt. Yeah,
I'm going to jump in. So typically, the problem we are facing in industrial companies is you have an OT process engineer. In this case, we assume it's a chemical process engineer, but it could also be an oil and gas process engineer that wants to create an early warning system for a reactor overheating. Now, this is based in the industrial site, in the plant, right? So typically, process engineers know exactly the signals. They know exactly what to do, but they lack the coding skills to do a predictive alert. They have typically no AI experience or machine learning experience. So what typically happens when someone wants to build this, they basically say, we need this. We talk to the IT in the enterprise department or in the IT department in the enterprise, and also the data science team to build this for us, right? Now, this normally not only creates delays, it also involves maybe even architecture decisions. It involves selection of software components. It's very complex. So it's kind of like you want to, and we have here the analogy, we want to run a simple Excel formula, but IT is the sole owner of Excel. They have the only license, and they also have to build something around it to make it work. So what we'll talk about today is Twinsight Machine Learning Workbench. It's a no-code tool It allows you to literally develop machine learning models using AI on live operational data. And we're going to show you exactly how that integrates with EOT as well as CrateDB software, right? So how does it all fit together in a real live example?
Thank you, Matt. It looks very exciting and empowering people with no coding knowledge to do this type of thing. So that's something we're going to cover in more details. So maybe as a short introduction also to CrateDB. So I'm Stefan Castellani, I'm SVP Marketing here at CrateDB. So just to give you a little bit of background on the partnership here with EOT, CrateDB provides a database. And we are a distributed database that offers speed, scalability, and resiliency. It sounds like very plain words, but in reality, it's extremely complex to have a system that is highly scalable, but also offers very high speed, regardless of the volume of data. And also high availability is very important. So CrateDB is built for very large volumes of data, for fast ingest, sub-second queries, and high concurrency of workloads. On the storage side, it's optimal and optimized for flexible storage to ingest any type of data, whether it's structured data, semi-structured data, unstructured data. And you leverage a columnar storage for very fast aggregations. And also you leverage the Lucene technology to make also some very fast search. It also automatically indexes all the fields. So regardless of the depth of your JSON payload, regardless of the complexity of your data, it can analyze and detect all the fields you have in your payload and index all those fields automatically. Also, something very interesting, and that's something that is very common when we deal with OT systems, the data coming from sensors may vary over time, and having the capability of having a dynamic schema is very important because as the data evolves or as the data format evolves, CrateDB can easily adjust with no need for maintenance or system interruption. So at the end, by combining all this type of data into a single system, we offer a unified data layer for analytics, search, and AI, where we can make complex joins, aggregations, full text search, but also vector similarity search when it comes to AI, your AI projects. All of that is done through a simple SQL interface. And in terms of costs, we are an open source product. And also we provide support, and also we provide a cloud as a service solution, CrateDB Cloud. And our pricing is based on the cluster size, not on the volume of ingestion, number of queries, and number of users you might have, which makes your cost very predictable. We can be deployed anywhere, and that's something we're going to cover more today. We can be deployed on any type of cloud, at the edge, also in a hybrid model or on-prem. So that being said, I will hand over to you, Matt, to get deeper into this world and this gap between OT and IT and the way you address it at EOT.
Thank you, Stefan. So EOT.ai is a company that provides 3 products. Together, they're called Twin Fusion. And what you can see here on the screen is what we classically have in industrial enterprises. We have an operations side on the left. And if you really look closely, you see it's a full stack that starts at the very bottom with operational data sources, data stores, with data models and historians, and then goes really into the operational analytics tools. Now, these are typically all located in a manufacturing plant or in a chemical plant or in an oil and gas field, right? On top of that, we have these tools that these operators need to actually keep all the systems working, right? They monitor, they make sure it works. On the right side, we have IT, and this is classic. We have the business data sources, from SAP to whatever. We have the business data stores and the business analytics tools. That's where the data scientists live, the IT department for the entire organization lives. Now, how EOT kind of connects these two worlds right? The enterprise IT organization and the plants, and there could be not just one plant, there could be tens of plants, sometimes even hundreds of plants that want to connect to this central IT system, and also the data lakes and everything else inside there. So how our software helps is basically a very unique approach. We have three software components. One is called TwinTalk that you see at the very bottom. TwinTalk is able to move data from the OT left side to the right side, and also from the right side back to the left side. So for instance, we can take data out of operational historians and move them in real time into CrateDB, which is a time series database, amongst others, right? So we can also take the data models with TwinTalk and move the metadata and unstructured data over into CrateDB in real time. So whenever something happens on the left side and people make changes to their systems, you will see it on the right side inside CrateDB. So TwinTalk allows this movement of data. Very important is that TwinTalk does not store data. It's not a another database. It just moves the data. It creates smart data pipelines. Twin Central in the middle is a product that allows to create coherent data models and unify them. So let's say you have a operational data model of one plant, let's say a manufacturing or a chemical plant, and you have another chemical plant and another chemical plant. Let's say you have 10 of them. How do you create an enterprise view inside the enterprise organization that is always up to date and is also connected to the SAP system? And you can merge these data models and have them, and use them inside the enterprise organization for data analytics, for hierarchy, navigation, and things like that. So the unified data access and the enablement of querying data models from and combining them from both sides, that is what Twin Central can do in the middle. So it's kind of like connecting graph databases, if you want. The last one, the one on the top, is TwinSight. TwinSight is a visualization solution that allows you to visualize data from the left side. So you have maybe operational historian data, and also you can visualize data on the right side. So you have, for instance, data that sits in CrateDB. So with that, you can create either dashboards and reports that are for the operational side, or for the enterprise side, or for both. You can also take existing operational dashboards and then create a counterpart inside the enterprise IT solutions. Let's say, back to our example, a chemical engineer, and you can use that as a template to roll it out to other industrial sites. I'm going to leave it at that. Sharon, do you want to add anything to that?
Well, I think the most important key kind of takeaway in terms of this Twin Fusion platform and the modules within it is that, again, just to reiterate, we don't store the data, right? So the data is kind of brought to the best of breed with the data store that you guys have that you want to run, like CrateDB, pulling it into a time series database, and then TwinSight and pulls that data directly from either and both, right, your IT side of the house and your OT side of the house, mashing up all of that data together.
That's great. Who wants to take this one? You, Sharon?
I'll start it. So now diving into our use case and our story around that chemical process engineer. Right? So in this case, the process engineer, they have and they hold all that critical operational know-how, the expertise, and they want to be able to iterate and kind of start building out some predictive systems. But yet, again, a lot of the challenges are around a lot of the data is in the IT world. There's coding involved. How do they start to move the needle forward and accelerate in some of these predictive models? And so what we've done is we've built out, as part of the TwinSight solution, we've built out the TwinSight machine learning workbench, which is a no-code kind of platform ability for folks to run their ML models within the visualization tool, right? So it's just point and click type of capabilities. So what we do is we allow your engineers, your plant managers, your folks that are sitting there out in the field to say, oh, this would be really interesting if we pulled in this data, this tag from this process, and then we looked at the temperature from this process, and let's see what we can do and start to kind of put this predictive early warning system in place and start to run with it straight away and to see how it works, and then how after a bit tweak it and kind of do that all with a no code environment. So we'll go into this in more detail, but if you could just stop and just switch over to the next slide. Yeah, thank you. So key capabilities. So what are the 4 things that we look at and we kind of are focusing on in terms of offering up the capabilities within this machine learning workbench, right? So if one, it's the train, upload and deploy ML models. Now, I think the key piece here is that it's on their real-time operational data. So if you think back to the software stack that Matt went through, right? So all of that is running in real time on operational data. It's moving it from the OT system into your CrateDB time series database. And then we have that integration, right? That where we have that data running in this, it's the data in motion, the data is moving through, and you deploy these models in your dashboard visualizations on that real-time data. It's not historical data, right? So it's your live data integrations. And like I mentioned, it is, in those live visualizations that you've already built and that you have running. And then this enables that fast time to value, rapid deployment of your predictive systems. Matt, do you want to take this?
Yeah, absolutely. Thanks, Sharon. What's interesting about this challenge is how do you even get started? That's typically the biggest question. Where do you start? How do you get started? And this is really quick how we actually allow an engineer, in this case a chemical process engineer, to actually, without coding experience, to actually make this happen. So the first is we are using the TwinSight machine learning workbench, and the machine learning workbench allows you to upload a machine learning model. Now, we are using ChatGPT to build the model and also train it. So very simply said, we are prompting ChatGPT with the challenge that we just discussed, one of the first slides, and then ChatGPT creates literally the Python script, so the code, and saves that. The code trains the model, and then the model itself will be saved as an ONNX file. So what will be saved is not the code; it's actually a trained a file that will then be uploaded into TwinSight. This way, it allows the engineer to do this without even writing one single line of code. Back to you, Stefan, or Sharon, if you want to add something.
Yeah, I can take it from here. Thank you, Matt. So the operational data streams from CrateDB into the model. as explained, running twin-site ML Workbench. And so CrateDB is being explained as a storage. So it's a database. It's used to store. It's also used to scale because when we deal with this type of data, we very easily get into very large volumes. And the goal also is to be extremely fast to infer data in real time. And so the model results are output to the twin-site dashboard. And then based on the outcomes, the engineer can iterate this process until the model is performing as expected. So it gives a full independence to this operational engineer, even though they are not AI experts or they don't have any training in machine learning. They can be independent and really test a lot of things without bothering or without waiting for the central AI team. And that's the beauty of this solution.
Absolutely. And what's interesting about this is, Stefan, this is how CrateDB and TwinSite works together, right? We basically have the data sitting in CrateDB, the model is uploaded, and please go to the next slide. These are literally the steps that we go through. This is a simple example. If you actually read the left side, right, how to have prompts for ChatGPT, how to create the machine learning model using AI assistants, like ChatGPT. You can also use other ones, and create the output that is needed for this process. Sharon, do you want to add anything to this?
Yeah, I think just to highlight one, that this is an iterative process, right? And you could leverage your public AI assistants like ChatGPT, you've got Claude, Amazon Nova. But also you guys are probably sitting there saying, well, maybe I don't have access to these public agents as well. So there's also the private ones that you can run this through. So we've used Amazon Q for business. And then also there's a number of custom ones. And we'll go into a little bit more detail in a bit of what else is available. But really, I think to highlight here is that what we want to do is break down the barriers and the walls to the machine learning model generation and deployment, right? So there's these AI agents that you can really start training the models, building the models, having it deploy it to an ONNX file. And then from there, you can deploy it, into your data pipeline with no code, into your visualization, running on real-time data. So we want to just make this available, right? And so the goal here is to put this power into the hands of the knowledge operators, right, within your industrial settings, and to make this as easy as possible. One, and then also to leverage the best of breed technologies that we have today, right? So if we think about this 3 years ago, this wouldn't even have been possible, right? So how do we leverage these capabilities in order to help organizations continue to drive value and to do it quickly and most efficiently?
Yeah. And when you explained that to me, Sharon, I decided to do it myself. So I took your script, I used ChatGPT and the basic version of it, and I came up with some interesting code. So that's very powerful. So here are the first two steps. So let's maybe move to the next slide where you have the other steps available, which is interesting. This is what you explain, right? Train an anomaly detection model and export your NNX file for deployment.
Right. And also you're asking from your score, right? So you're also asking it to generate, well, what is my accuracy? What do you so you can also monitor and to say, okay, well, I need to improve my accuracy. I need to improve my score here for this model. Right. So it gives you such power. There's so much power in the hands of the non-developer, right? Which is what I love. I've spent many hours and days sitting next to operators, right? And they really hold the knowledge, and I can't emphasize that enough, right? They hold the knowledge and the understanding of their plants, of their facilities, of their refineries. And so this really, I'm excited about this because it helps kind of open that up and to allow kind of that faster iteration. And that they literally just kind of create and have that convert the trained model, right, which is your Python code. You can see that Python code on the right, and save it out to a file, right? It's like an Excel file. And then from there, if you could jump down to
next slide.
Oh, actually, we go into now just examples of these private no-code models, right? So Amazon Q for Business, this is the prompts that we entered and kind of got that Python code out in that case. And I would also highlight and suggest, if you have access to multiple agents, run the same prompts and the multiple agents and see what happens, and do a side-by-side comparison of the output and the results. But just a kind of a highlight for kind of the Amazon Q for Business. It's kind of that fully managed AI assistant that's for enterprise users. It kind of comprises, it requires authentication, authorization. So you've got more of that security around it if you're needing it for your organization. And then other options which are also out there. There's a number of them, right? And so I'm just highlighting a few here. You've got Amazon Q Developer, which does require a little bit of code. So that's more on the coding side. And then also you've got, custom chatbots that you can build internally in-house, built on some of the other foundation models that are out there. And then if we can just jump to this. So this is great. So this is the UI, right? So you're saying, okay, well, you've heard us talking about how simple and easy this is, right? So you literally are navigating over to your Onyx file, right? And so you're selecting that and you're uploading it into your TwinSight dashboard. And from here, you can see that we have the select statement, right? So we're pulling in the data from CrateDB. That data is live streaming into your dashboard. And then as you turn on your ML processing, it's just a toggle button, right? Once you have everything set up, once you have the Onyx file there, it's a toggle button and it starts running that model in real time on those live time series data streams that are coming in from Crate. Matt, is there anything you wanted to add to that one?
Oh, sorry.
No, we can move on to the next one. So I'm going to take this one and just kind of explain here a little bit the user interface. Basically, we have something super simple here because we want to make it very digestible and understandable for the audience. But basically, you have the TwinSight machine learning Workbench user interface showing data from CrateDB, also showing data from an operational system, and two machine learning models that runs on the left and the right side. So remember when I said with the OT silo with all the operational stack, and we have the IT silo with all the stuff there. Here we have one single dashboard showing data from both sides of the universe, so to speak, both running the same machine learning model against the real-time data. Let's go to the next slide. So you might think, how does this all work? What's happening behind the scenes? How does CrateDB get the data, and what's the architecture like? It always comes down to the architecture. Specifically, if there are architects or chief architects or solution architects in the audience listening to this or watching it, this is the architecture that kind of explains how the components work together. So on the left side, we have the industrial plant. This is the OT side with the data sources there. We have TwinTalk, which, if you remember, is the product that moves data. So TwinTalk moves the data into CrateDB. It also moves the data and allows the TwinCentral component, our other software product, to get the data models and the metadata that's hierarchy based, right? Now, on the right side, we have TwinSight and the TwinSight machine learning Workbench that uses Pandas and SQL Alchemy and Python to basically get the data from CrateDB and display that then dashboard. at the very bottom, we also see what Sharon earlier mentioned, the different Gen AI and AI builder tools, ChatGPT, Claude, we have Amazon Nova, we have Amazon Q Business. There could be also some custom built AI assistants that can be used to do that. It normally all depends on what your company, if you're on, working for an industrial company, allows you to do from a security perspective. Will you have access to a public AI assistant? Highly likely not, just my experience. You will probably have some sort of enterprise AI assistant available to you. But that's kind of just in a short, brief moment or minute, the architecture that's making this all happen and how it kind of all works together. Back to you. Oh, we have one more slide that explains
one more, yes.
TwinTalk. So actually, can you just go back 1 second?
1 second, yes.
So we see here TwinTalk and CrateDB in the middle. You see that line that goes from TwinTalk to CrateDB. Now, please forward one slide. This is basically what you see here, right? TwinTalk allows you to create these data pipelines. And I'm not going to go into detail here, but basically, in one sentence, you can create use case specific data pipelines. Let's say in our example, the chemical engineer that wants to create a warning system if something goes wrong. You select just that information from the OT side, you move it into CrateDB. CrateDB can or is connected with TwinSight machine learning Workbench, and you can just create a use case specific dashboard for that. So it's a very almost surgical way to not move all the data for all the stuff into CrateDB, but only the data you really need. Back to you.
And also, sorry, I'd also add that it's the data in the format that you need for that model, right? So that particular aggregations, particular interpolations, so that the data is ready to be consumed by the ML model.
Absolutely.
So thank you, Matt. Thank you, Sharon. So just to maybe spend a few slides to go a little bit deeper into CrateDB. So I won't repeat what I already said, but just something to remember is that CrateDB can accept any type of data, whether it's structured, unstructured, or semi-structured. It's also very flexible. It can be created with native SQL. So in terms of knowledge, it's very easy to use CrateDB. And it's a highly scalable database that leverages columnar storage and can scale to thanks to a horizontal scaling. We can easily add more nodes, and the performance remains and stable and as the volume grows, which is a big strength of CrateDB. When it comes to data sources, as you explained, we get the data from TwinTalk. We can also get the data from other sources if needed on the IT side as well. CrateDB can be deployed either on the IT side, on the cloud, or on public cloud, private cloud, but it can also be deployed on the edge, which is also an interesting aspect of CrateDB. In terms of use case, you can easily query the data to make very fast aggregations in a matter of less than a second. You can also combine your aggregations with other queries. You can also make some search, whether it's full text search or vector search for AI projects. And you can easily connect to your visualization tools and also your AI ML frameworks. So in terms of time series data, this is something we brought up, time series. So CrateDB can accept time series data. It manipulates time series data very well. It can also combine time series data with many other types of data. But when it comes to time series data themselves, we have a lot of native functions available to extract time, to make some time bucketing, to make some window functions, also handling null, making some statistical aggregates, some advanced filtering and logic. And also, we can leverage some interesting features of CrateDB, which is partitioning, sharding, and dynamic schema. Just to give you an example of what it looks like from an SQL perspective, I mean, It's not as, I would say, straightforward as for ML Workbench. I mean, you need to have a minimal level in SQL, but for anyone used to make some SQL queries, you can see the standard syntax where you can make your user-defined functions. You can also make some leverage embedded native functions to get what you want in terms of moving average, in terms of window filtering, and so on. So very easy to consume your data. Also, if you get some JSON data that is in a specific structure, you can easily access any field into the JSON data thanks to the bracket to the bracket pattern here to access the data into the JSON field. I would like also to talk a bit about AI. I mean, we've talked about machine learning, and let's talk also about other types of AI, such as Gen AI or the new agentic AI concept that is coming up. It's very important when you run your AI projects, whatever they are, that you can manipulate these different types of data. Because at the end, the value resides in what you're analyzing in this data, not about, and you don't want to get into new silos. You don't want to just query a specific silo and don't have the full visibility on your data. So the holistic view is very important. Also, data sources in AI pipelines are unpredictable and rapidly changing, which means that you can have new sensors, your sensors format can evolve over time. You might get new field, you might get a new format. So having some custom schema flexibility is key, and that's what CrateDB provides out of the box. So you don't need to, every time there is a change, to turn down your system, to make some maintenance for a few minutes or hours, and to make the changes with some thorough testing. It's made out of the box. And also, what is important with AI and CrateDB, that AI doesn't know immediately what data fields they need. If you want to make some exploration of your data, at some point you need to make a lot of tests and iterations. So the beauty of CrateDB is that it can index all the fields by default, including the one deep dive into some JSON structures. So whatever the query you're doing, at the end you get the best performance, and you don't need to get into complex optimization systems to fine-tune your queries. So very quickly, so CrateDB can ingest the data at very high ingest rates. It is meant to scale for very large volumes. Internally, CrateDB leverages columnar storage for fast analytical queries and reduce I/O. We can query billions of rows in a matter of milliseconds. And in terms of breadth of queries, you can make also complex joins, which is very interesting. You can join any data, any field, and you can combine your aggregations with full text search capabilities and vector embedding and similarity search, all using SQL. Also, lately, we embedded an MCP server to allow communication between LLMs, which is a new trend right now among the different platforms. So here are a few examples of volumes we are addressing. So the first example is SPGO. It's a company specialized in mining. They have tons of sensors on the field. They are sending tons of data that needs to be analyzed in real time for real-time analytics and also predictive maintenance. We also are having a customer specialized in warehousing, TGW logistics, having sensors across the different warehouses, and they are monitoring all the touts going in and out per hour. And at the end, it's a massive volume, and it needs to be analyzed in real time to avoid delays and avoid unpredictable results. I will cover this slide very quickly. It's very important to have a cost-efficient model. So CrateDB is meant to scale. It's meant to be fast, but the cost model is very efficient. Not only from an architecture perspective, the architecture is meant to be extremely efficient by design, and also in terms of options we have. We can make things highly available. For example, you can define the number of replica you want to have on your cluster, so you can define the level of high availability you need. And also in terms of deployment, it's very important to have a technology that can be deployed wherever you want, whether it's on the cloud, on your own cloud, on premises, on hybrid mode, or at the edge. And we have an open source core model. And then you can use our CrateDB cloud service that is available via our website to have everything already fully managed for you. And in terms of maintenance, this is also something our customers are very happy with, is that the time and the effort to maintain this cluster is very low. So that saves you a lot of efforts and resources to focus on more important things than just maintaining your cluster. So we are getting to the end of this discussion. We have received a few questions that we will go through. But before that, Sharon, if people want to learn more about EOT, where should they go?
Sure. So I've added the QR code here to schedule a discovery session. We can deep dive into your particular situation and use cases and challenges within your organization, and talk through our Twin Fusion product in addition to the ML Workbench. So that QR code's available there with the URL. And then also I've included a link right to our ebook, which we've titled "Avoiding, the AI POC Purgatory." Right. So I think we've all heard and are aware of the percentages of number of ML projects that end up, for one reason or another, are not deployed right across the enterprise. And so what we really want to help customers with is to get themselves and their organizations to deployable ML models and deployable AI projects. And the way to do that, and the way that we really approach this, is looking at it from a use case point of view, right? And so I think we've touched about it a little bit earlier, is that when we are talking about Twin Talk, right? So the data pipeline that moves the data from the OT to the IT side, right? We do that from these curated data pipelines, and these curated data pipelines, we look at them as being very use case specific, right? So what does that particular model need? So we think of everything that we're doing here with the lens of the use case. And so this ebook really helps go through step by step kind of how to think through and identify those use cases within your organization that drives value, and that you can then start to prioritize and use in terms of the kind of the models and the projects that you are then deploying across your organization. So that's available as a download. So please feel free to go and grab that, and I hope it's useful.
Thank you, Sharon. And for CrateDB, you can go to cratedb.com, where we have a lot of interesting resources available, white paper, videos, but you can also go to the Academy if you want to learn how CrateDB works. That gives you at the end a certification of completion. So nice place to get started if you want to explore more CrateDB. So before we wrap up, Matt, Sharon, I have a few questions here. We have a few minutes left. We can cover them. So maybe for you, Sharon, what are the most common challenges industrial teams face when trying to implement machine learning on their own? And how does the DIY approach help overcome them?
So yeah, this is a great question to summarize what we've been talking about here today. In terms of the tools that are available, up until now, many of them require some deep development engineering expertise, technical expertise, of which what we're looking to do is to really put this ability to utilize their data, OT data, right, for these predictive models, and put that into the hands of operators, plant managers, reliability engineers, process engineers, right? So in terms of that, right, so the challenge is really is getting that access, right, and to make it turn this into a kind of a no code, easier kind of ability to play with the data, play with the ML models, deploy it, iterate, right, and get it to the place where they can see results and start building out early warning systems.
Yeah, great points. I see one also on the combination of CrateDB and EOT. How does the combination make machine learning both accessible and scalable for specific use cases in energy and manufacturing? So maybe I can take this one. I think at the end, I mean, EOT provides everything you need to be successful, to synchronize your data between OT and IT, to make sure you have access also to machine learning mechanism without necessarily having the knowledge. And below that, you need an infrastructure that can scale. I mean, that's what we said multiple times during this webinar. It's the importance of having something that is not only fast, because you need to get access to the data really fast to infer the data in real time, but also you need to scale. And that's often the challenge companies are facing. If their solution is not able to scale, they are getting into some trouble, and at some point they need to think of other solutions. And so it's very important when you experiment to of course start small, but to make sure that the data the solutions you're leveraging are meant and designed to scale.
Yeah, and I'll add that, you know, one of the, I think the key value props of the EOT and CrateDB partnership, you know, is that ability for Crate to scale. We see customers that struggle in their surveillance, you know, building out their surveillance and monitoring tools, monitoring their data in real time, running their analytics, you know, in near real time. And the ability for Crate to handle those large volumes of data, not just handle the large volumes of data, but also the analytics and the data processing that comes with it, really helps. It enables that real-time monitoring that operators are looking for.
Yes. And there is one person asking for a real-world example where visual no-code ML tools significantly reduce the time from data ingestion to actionable insights on the factory floor. What is, in your opinion, Sharon, I mean, based on your experience, what is the time people save, you know, when using ML Workbench? Did you get some comparison? Were you able to measure before and after what it took?
Yeah, I mean, to be fair, every organization's different, every company's different, right? And what their process is, but it reduces weeks into months. And also, what's really important is that it not only reduces from, I would say, a couple months, we're looking at weeks, 6 to 8 weeks type of thing, but also on average, but also what's most important is that it gets into the hands of the end users straight away, right? And it's running on real-time data straight away. And so that iterative approach, it's really, we see that's where the value is, right? So you're not waiting, right? Somebody's not waiting 2 months before they get the request into the queue. It then gets, prioritized and starts to get worked on. And the time that it reduces the end user, an end user can have something up and running in a day or two, right? So which just it helps that with that iterative kind of fast process, fast learning.
And I think this speed also foster innovation, I would assume, given that they don't need to wait anymore. So new ideas come to their mind and they experiment more, and at the end maybe they get into interesting insights they never thought of in the past.
Yep. I like to think of it like an onion, right? So like you don't know what's on the inside of that onion, right? So each fast iteration, you're peeling back the layers of the onion, and you don't know what you don't know yet, right? And so it's a quick way to start accelerating through that.
Yeah, that's great. So we're getting to the end of this live stream webinar. First of all, I would like to thank you very much, Matt, Sharon, for your time. We are very excited here at CrateDB to partner with you, and this combination of solutions brings a lot of value to bridge the gap between OT and IT. Anything you would like to add, Matt, before we leave this call?
Well, Stefan, it has been a pleasure. I think this combination that we discussed today is one of the most powerful solutions that's currently in existence for this problem. And I can't wait to hear more from customers And from people who visited or people who watched this this live stream, like, please contact us, send us a quick note. That would be awesome.
That's the message. Yeah, it's being delivered. No, thank you both. So this live stream webinar was brought to you by CrateDB and EOT. Thank you again, Sharon. Thank you, Matt. And this recording will be available on YouTube and LinkedIn, on our different YouTube channels and LinkedIn pages. Thank you very much. Have a great end of your day. Bye-bye.
Thank you.
Thank you.